Welcome to Generation AI, the show where we explore how AI is reshaping our generation. I'm Derek Stahl. On the show today, Arizona is poised to cash in on a generational investment, all thanks to the fervor surrounding AI. TSMC just announced expansion plans, massive expansion plans for the company's facility in North Phoenix. Let's take a look at some of the numbers here. So, Taiwan Semiconductor Manufacturing Company announced plans to invest another $100 billion in its facility in North Phoenix. It's planning 4 more chip fabricating factories, or Fabs, and that brings the company's total planned investment to $265 billion. If you're wondering, that's going to bring their plans to build up to 10 Fabs in North Phoenix, along with 2 advanced chip packaging facilities and a research and development center. The expansion will go on the new 900-acre campus the company acquired earlier this year. TSMC saw their profits jump nearly 80% this quarter to just over $22 billion. And company executives say this expansion is all to keep up with soaring demand for computer chips from what they call the AI megatrend. Now, there's no timetable yet on the pace of this build-out. The company says it'll all depend on the market. So for now, it's just a promise and a plan for future investment. But local economists are excited, and they expect it'll have a major impact on jobs. So speaking of jobs, right now, TSMC has more than 3,500 employees working on one fab, which started production in late 2024. They have built a second fab, but it's not up and running yet, and they've broken ground on a third fab. The company expects the first 3 fabs will eventually employ 6,000 people. The company hasn't released forecasts beyond that in terms of jobs, but one ASU economics professor, Anthony Howell, estimates this new investment is likely to mean 10,000 to 12,000 construction jobs and another 12,000 permanent jobs once it's all in operation. He says a third of those permanent jobs are what they call high-tech jobs, and high-tech jobs have major implications.
There is a multiplier effect, which in the literature shows that for every one high-tech job, there's around 3 to 4 additional jobs that get created kind of down ancillary effects. So that could be actually 40 to 50,000 jobs once you take into account multiplier effects. But a lot of those jobs are maybe service sector jobs and things like that that kind of support high-tech, job creation as well.
Creating jobs is one thing, filling them is another, and there's concern Arizona needs to do much more to keep up with the work, to train these highly skilled workers. Since TSMC set up shop, state universities and community colleges have scaled up workforce training programs. But Jim Rounds with the Rounds Consulting Group says a new report he worked on with the Board of Regents shows the state is facing a deficit of about 10,000 high-skilled jobs per year. That means 20,000 jobs by year 2, 30,000 jobs by year 3 if it's not addressed.
We have a lot of different workforce training organizations, but where I feel like we're not maximizing opportunities is I'm seeing a lot of disconnect between some of these workforce development organizations. If we kind of coalesced, if we brought everybody together for the same amount of money, we could be training maybe, I think, double the amount of people that we currently are. So it's inefficient because we're in a situation where we're growing high-wage jobs and nobody could have predicted it at this scale. Economics doesn't like imbalances. So either the economy is going to slow or we're going to produce those extra workers to catch up to what demand is going to be. I feel like we can do that. This is how we responded to the Great Recession. This is another pivot point in our economy and our public policy procedures. We need to start increasing production. We need to have academic achievement levels go up across the board.
Round says Arizona needs to work on building out its skilled labor force so the state stays ahead of other states, other places where companies might locate. He said this legislative session will be crucial to invest in these programs. Now, we've got much more coverage of the TSMC expansion after the break. Coming up, why this project is far more significant in terms of water than data center developments. We'll take a look at the numbers and what kind of impact it could have when Generation AI continues. There's a lot of talk surrounding AI and water use. We've covered it before on this show. It comes up a lot in debates over data centers. But the TSMC facility in North Phoenix uses far more water than a typical data center already. And the company's expansion could make it one of the largest industrial water users in the valley and maybe even in the state. There are caveats, though. My guest today is going to explore all that. She is Sarah Porter, director of the Kyle Center for Water Policy at Arizona State University. Sarah, welcome to Generation AI.
It's nice to be with you.
Oh, I'm so glad you're here because you're the expert on all this. And I kind of want you to just start by sort of setting up the scale. So if TSMC Arizona reaches full build out with 10 fabs, 2 packaging facilities, where might it rank on the list of Arizona's largest water users?
It's a hard question to answer because the largest water users in the state tend to be agricultural water users, and then mining uses a lot of water. Power production, particularly nuclear power production, uses a great deal of water for cooling. And those uses they're not using the city of Phoenix's tap water for agriculture, mining, and power production. So we're a little bit comparing apples and oranges. But I would say that if they build out, TSMC will unquestionably be one of Phoenix's biggest customers, if not the biggest customer for tap water.
Let's look at a chart that you put out in a report a few months ago where you looked at the largest water users and you broke them down by category. So at the top of the list, we've got things like power generation, which can use up to 100,000 acre feet of water. I think the largest water user in central Arizona is the Palo Verde nuclear generating station. Then the category right below that is semiconductor manufacturing, and then sand and gravel mining, golf courses, beverage facilities, which we often don't talk about, those beer makers out there. And then way at the bottom of this particular list is data centers. And we know that, the one fab at TSMC uses about 5,300 acre feet of water. So put that into perspective for us. How should we be thinking about all this?
The most important thing to think about is withdrawals versus consumptions in water nerd language. In other words, net consumption matters more than how much water they have delivered. So some of those industries on the list have very little ability to reclaim and reuse the water that they take. An example is a golf course. Most of the water used for a golf course goes on the grass, the turf, and that water evaporates or evapotranspirates. So almost all of the water a golf course takes on board is going to be consumed, in other words, taken out of the control of the local community or the user. In the case of semiconductor manufacturing, and this is super important, there is a high capacity to reclaim the water. One of the biggest uses for water in semiconductor chip manufacturing is they treat the water to ultra pure, which is needed to, as I understand it, wash off the chips in the production process. That water, once it's washed the chips off, is full of stuff you don't want in it if you're going to reuse it. But a manufacturer like TSMC, and this is also true of Intel and Chandler, can reclaim that byproduct water and treat it. They treat it again to ultra pure so that they can use it again. TSMC is now reclaiming at about a 65% rate, so that lowers their net consumption significantly. In the future, they have a stated goal of a 90% recycling rate. They actually have broken ground on a big industrial water reclamation plant, kind of a state-of-the-art facility, so that they can get to their stated goal of a 90% reclamation rate. So in that case, even if they take a lot of water, and they will, compared with other industries or other customers of the city of Phoenix, it's not really as much as you might think, because they're reclaiming it, bringing their net consumption of water down, to a fraction of the kinds of numbers we're talking about here.
That makes a lot of sense. Now, you published a report earlier this year that argued, the most important question is essentially not just how much water a project uses, but also where the water is coming from, how much is actually consumed, which you touched on there, how much is recycled, and then what Arizona ultimately gets in return. So I kind of want to break down some of those questions one by one. Can you talk a little bit about where is TSMC actually getting its water? Because we know that, some water sources are more, rechargeable, renewable, and others are not.
That's absolutely right. So the city, it gets its water technically from the city of Phoenix, just as I, a resident of Phoenix, get my water from the city of Phoenix. They have a bigger meter, but the water that Phoenix delivers is from a diverse portfolio. But so that includes water from the Salt River Project system, the Salt and Verde Rivers, water from the Colorado River system, groundwater, very small amount of groundwater, which we should talk about, and then reclaimed water, which is water that the city of Phoenix has treated from its own wastewater system. So the city of Phoenix takes its, the water that we flush or send down the drain and treats it and reuses it for all kinds of purposes, including sending cooling water to the Palo Verde nuclear generating station. In the case of TSMC, it'll be getting its water from the city of Phoenix, and probably most of that water, because of where TSMC is located, will be water from the Colorado River supply that's delivered via the Central Arizona Project Canal. A thing about groundwater, and the reason why this is important, is that when we take water from aquifers in Arizona, unless we have requirements for recharging those aquifers, we are generally depleting those aquifers because it takes so long for precipitation to convert to, significant amounts of water.
Right. But so Phoenix uses very little groundwater, right? Just about 1%. So very little is that
percentage.
Yeah, that unreturned water. But because TSMC is leveraging the city of Phoenix for its water, it's using, I think, what in water policy people talk about as a designated assured water supply, right? This is like a 100-year promise that there will be water. But the city of Phoenix, in my understanding, only has so many of these 100-year golden tickets to sort of hand out, right? So if TSMC is using a large allocation of this 100-year promised water, does that mean it makes it harder for housing to get built in North Phoenix?
It means that the city needs to balance its, the water it allocates in its portfolio. It's actually the city that has this designation of assured water supply. It's very desirable for a city to have that because it enables the city to control water demand within their service area. So when the city makes a decision to do something like support TSMC with water, they are thinking about, do we have enough water for the housing subdivisions that we want surrounding the plant, for the workforce to support the plant, or for the other industries that they want in the region. So yes, the city's water portfolio is not limitless, and the city, that designation forces the city to think about, do they have enough water for 100 years to serve the commitments that they've made and that they're planning to make.
We know that the Colorado River supply has been shrinking. It's something we cover a lot here on Arizona's Family. Does that make it more challenging as that supply decreases, to make large promises to large industrial users like TSMC who want to come in and build 10 fabs?
Yes, it certainly is more challenging when the city and all the cities that rely on Colorado River water are looking at having less of that supply. The good news is that most of the cities that use Colorado River water actually don't use all of the Colorado River water that they have in their portfolios. They haven't built out demand for all of that water, so they can absorb some degree of shortage, of cuts, without having to scramble and find other water supplies. But what your question is so important, that it's critical for Phoenix and Central Arizona cities to be looking at commitments to water service in this way, that thinks through what are the benefits, what are the benefits to the community of this commitment to serve water.
Well, I want to get to that question, but let's do it on the flip side of the break. So we're going to have much more with Sarah after this, diving into the question of what is Arizona getting in return for all of this water. We'll explore that when Generation AI continues. Welcome back to Generation AI. I'm here with Sarah Porter, the director of the Kyle Center for Water Policy at ASU. Where we left off, where we're talking about the TSMC expansion in North Phoenix and the question of what is Arizona getting in return for all of this water? Because we know each of these fabs in North Phoenix requires quite a bit of water to cool down the chips and clean the chips as they make them, although the company is doing a lot of recycling efforts, certainly for all this water. So Sarah, what do you say to the question of what is Arizona getting back? Is it worth the water?
Well, is it worth the water is a very subjective question that the city of Phoenix has answered by saying, yes, we are going to serve TSMC. But what was the reason for that? Why did they decide that? One of the things that semiconductor manufacturing offers is very high paying, a lot of high paying jobs. And so for each fab, we can expect about 1,800 well-paying jobs. In addition, of course, there are all the trade worker jobs that occur while these fabs are being built out. And anyone who's, driven from Phoenix up north, over the last few years has been driving by that facility as it grows and grows. We can just imagine the thousands of tradespeople who are working on building out those facilities and will be for years to come. On top of that, the city and the state of Arizona can derive tax benefits from property taxes, from income taxes, even from sales taxes because of all of the new activity in that part of Phoenix. When we look at the sort of return on water investment, something like a semiconductor manufacturing plant is pretty easy to defend compared with some other industries.
Now, the company has released one forecast in terms of job totals for their expansion. They've predicted that they'll have about 6,000 jobs once they complete Fab 3.
Yeah.
They haven't released job forecasts beyond that. We've been getting a lot of outside experts weighing in on how many jobs are created. But I want to sort of pose a hypothetical to you. Let's say the fabs of the future take a while to build. They're many years down the road. And let's say the fabs of the future are much more automated and AI generated and robotic and have far fewer human jobs attached to them. Are they still worth the water if, say, they have half as many jobs we're expecting?
They may not be, but we can't answer that question until we know about what are the other uses for water in this highly automated, AI-dominated world. So it may be. Maybe there will be other ways that the state can derive and city can derive benefits from a facility like that. There are too many variables to answer that definitively now.
Yeah, I guess, I just wonder, the company has promised to build 10 fabs, but it's not like the city of Phoenix, the water resources folks, it's not like they've committed to giving them the water necessary for 10 fabs, right? That's a sort of an ongoing discussion that'll be voted on periodically over time. Is that right?
That's my understanding. And really the city of Phoenix and TSMC have been trying to work together to sort of make sure that the resources are available without any kind of impact on other users at the time that TSMC, ramps up the need for them. It's really it's more of an evolving collaborative development, I would say.
I've seen some reporting in Taiwanese media that the TSMC folks have, encountered some challenges or maybe more challenges than they expected trying to get the water necessary. And I'm just wondering, kind of behind the scenes, how much of the work to acquire the water they need is on the company versus is on the city of Phoenix water folks?
Well, as I say, they really are trying to work together. And I'll, you know, TSMC is even looking beyond its own needs and has been looking at what can it do for water in other parts of the city. They're working on making investments, for example, in the irrigation infrastructure in city parks to, you know, they're trying to sort of go beyond, you know, the TSMC campus here. But to date, it has been on Phoenix to make sure of having the water supplies to serve TSMC. When Phoenix acquired the state lands, which had kind of been earmarked for Phoenix for a very long time in that north part of town where TSMC is being built, it also acquired a right to Colorado River water that the state lands department held at that point. So that has been the kind of presumptive supply for that large part of Phoenix, TSMC and beyond, up and, you know, and since the deal was announced. As we look at Colorado River shortage and its impacts on cities, Phoenix and other cities are working on developing alternative water supplies. This is going to, you know, create costs for the water utilities for the cities as well as for the ratepayers in the cities. And my expectation would be that large water users like TSMC will be involved in conversations with their cities about being as efficient as they possibly can, so that the city isn't investing beyond what it absolutely needs. I think that's part of the reason for TSMC's very ambitious 90% recycling goal.
Earlier on in the conversation, we were talking about the idea of a designated water supply, the 100-year water supply, and the idea that, you know, for every acre foot of water that's granted to TSMC, the city of Phoenix can't necessarily, you know, grant an acre foot of water to somebody else. Based on how those decisions work and how the shuffling works, do you anticipate there could be any fallout? We talked about this a little bit earlier, but I mean, is it possible that the city might not be able to expand in other areas of, you know, the region?
Yeah, I don't see that happening even with, I mean, I don't see it happening in the real world of the world of things that are likely to be proposed. There may be proposals for industries that the city absolutely rejects because they don't think the water is worth it. But the city has enough flexibility in its portfolio, a very large supply of stored groundwater, and is already working on alternative water supplies. So I certainly feel pretty confident that TSMC is not going to be, you know, the thing that stops Phoenix from being able to continue to grow economically and have new activities that require water. But without question, it's a big water user, and cities need to think through their commitments to large water users.
Off the top of the conversation, Sarah, I made the comparison between TSMC and data centers, and I said, you know, TSMC already uses much more water than a typical data center. Throughout the conversation, you've been talking about all of the ways in which TSMC has, you know, is working to recycle its water, reuse water, you know, the investments that come along with it. When you think of what's worth the water, semiconductor manufacturing or data centers, how do you, you know, assign the value there?
Well, I love all the things that data centers do for us. I am addicted to my cell phone. I stream movies. I do my banking online. I'm talking to you over data center provided services to be able to have a remote call. So I think data, you know, we can't simply say data center's bad, semiconductor manufacturing good.
But which one is worth putting in the desert in Arizona, I guess is what I'm saying.
Well, it depends on your data center. As data, you know, we're in this amount of crazy data center development pressure, as you know well, and data center proposals in the West have tended to propose closed loop systems or much lower water use systems. And so how do we compare a data center that doesn't provide very many jobs does provide critical services that almost everyone uses, and uses very little water, compared with a semiconductor plant that employs a lot of people, may consume a lot more water, but may provide a lot more revenues and other benefits. Very, very hard to compare. If somebody came along and said, we're going to develop a data center that will use old-fashioned evaporative cooling, we're going to pump water out of the aquifers in order to cool a data center that's going to provide 50 jobs and maybe some good tax revenue to the local government, I might be, saying, could we review this? Like, what's in it? What's the benefit? But that's the challenge with data centers. Data centers can provide local benefits. They can provide tax revenues that are important to cities. They may provide some good jobs, and they don't ask for much. They don't ask for schools. They don't ask for a lot of policing. They don't ask for new roads. So in some respects, data centers are sort of easy to accommodate, but when they ask for a lot of a community's limited water portfolio, that's when I think a community needs to look at the trade-offs very carefully.
Yeah, it's a fascinating discussion, and I think with anything with water, there's a lot of nuance involved, so we appreciate you. Sarah Porter is the director of the Kyle Center for Water Policy at ASU. Sarah, thanks for being on Generation AI.
It's been great to be with you. Thank you, Derek.
Thank you. And thank you for watching Generation AI. You can catch us Wednesday nights, 7 p.m., streaming on AZF+, or you can find episodes anytime at azfamily.com/GenAI.